Hello everyone. This is Mr.S.M.Utage working as Assistant Professor in Mechanical Engineering Department, Walchand Institute of Technology, Solapur. So today we'll be discussing about the measurement learning outcomes. At the end of this session, students will be able to explain about different methods of measurement. Students will be able to explain about precision and accuracy. The following contents will be discussed in this video lecture: measurement, methods of measurement, precision and accuracy. Measurement. It can be defined as the act of obtaining quantitative information about a physical object. It can also be defined as the set of experimental operations carried out to determine the value of quantity. Process of measurement. The sequence of operations necessary for the execution of measurement is called as process of measurement. There are three important elements of measurement. One is the measurand, second one reference, third one comparator. Measurand. It is a physical quantity or property like length, angle, diameter, thickness, etc. to be measured. Reference. It is a physical quantity or a property to which quantitative comparisons are made. Comparator. It is the means of comparing measurand with some reference. Suppose a fitter has to measure the length of a MS flat. He first lays his rule along the flat. He then carefully aligns the zero end of his rule with one end of the MS flat and finally compares the length of the flat with the graduations on his rule by his eyes. In this example, the length of MS flat is the measurand, steel rule is the reference, and eye can be considered as a comparator. Now pause this video for a few seconds and try to write answer to the following question. State true or false. Length is a measurand. Probably you have wrote answer to the following question. Depending on the accuracy required and amount of permissible error. The different methods of measurement can be classified as direct method, indirect method, absolute or fundamental method, comparative method, coincidence method, deflection method, complementary method, contact method, contactless method. Direct method of measurement. This is a simple method of measurement in which the value of the quantity to be measured is obtained directly without any calculations. For example, measurement by using scales, as you obtain the direct reading. So this is a direct method of measurement. Indirect method of measurement. Indirect method of measurement. In indirect method, the value of quantity to be measured is obtained by measuring other quantities which are functionally related to the required value. Example, angle measurement by sine bar, in which you are finding the angle by using the height and the distance between the roller. The height is nothing but the slip gauge height, and the distance between the roller is in the sine bar is already given. So then you are finding the angle measurement. So then you are finding the angle. Absolute or fundamental method. It is based on the measurement of the base quantities used to define the quantity. For example, measuring of the quantity directly in accordance with the definition of that quantity, or measuring a quantity indirectly by direct measurement of the quantities linked with the definition of the quantity to be measured. Comparative method. In this method, the value of the quantity to be measured is compared with known value of the same quantity or other quantity practically related to it. So in this method, only the deviations from a master gauge are determined. Example, dial indicators or other comparators. Coincidence method. It is the differential method of measurement in which a very small difference between the value of a quantity to be measured and the reference is determined by the observation of the coincidence of certain lines or signals. For example, measurement by vernier caliper micrometer. Deflection method. In this method, the value of the quantity to be measured is directly indicated by deflection of a pointer on a calibrated scale. Complementary method. In this method, the value of the quantity to be measured is combined with the known value of the same quantity. The combination is so adjusted that the sum of these two values is equal to the predetermined comparison value. For example, determination of the volume of a solid by liquid displacement. Contact method. In this method, the sensor or measuring tip of the instrument actually touches the surface to be measured. For example, measurement by micrometer, vernier caliper, dial indicator, etc. In such cases, arrangement for constant contact pressure should be provided to prevent errors due to excessive contact pressure. Contactless method. In this method, there is no direct contact with the surfaces to be measured. Example, measurement by optical instruments such as toolmaker's microscope. Measuring system. A measuring system is made of the 5 basic elements. These are standard, workpiece, instrument, person, environment. The most basic element of measurement is a standard without which no measurement is possible. Once the standard is chosen, a measuring instrument incorporating this standard is to be obtained. This instrument is then used to measure the job parameters in terms of units of standard contained in it. The measurement should be performed under standard environment, and lastly, there should be some person or mechanism to carry out the measurement. So let us now discuss about precision and accuracy. Precision is the repeatability of the measuring process. It refers to the group of measurements for the same characteristics taken under identical conditions. It indicates to what extent the identically performed measurement agrees with each other. If the instrument is not precise, it will give different results for the same dimension being measured again and again. The set of observations will scatter about the mean. The scatter of these measurements is designated as sigma, the standard deviation. It is used as an index of precision. The less the scattering, more precise is the instrument. The lower the value of sigma, the more precise is the instrument. Accuracy. It is the degree to which the measured value of the quality characteristic agrees with the true value. The difference between the true value and the measured value is known as error of measurement. It is practically difficult to measure exactly the true value, and therefore a set of observations is made whose mean value is taken as the true value of the quality measured. Now let us try to understand what is the difference between precision and accuracy by the following example. So here the measurements are made on a component by different types of instruments A, B and C respectively, and the results are plotted. Figure 1 shows that the instrument is precise since the results of the number of measurements are close to the average value. However, there is a large difference between the true value and the average value, and hence it is not accurate. In figure 2, the readings taken by the instruments are scattered much from the average value, and hence it is not precise but accurate, as there is a small difference between the average value and true value. Figure 3 shows that the instrument is both precise as well as accurate. These are the following references. Thank you.